Hiya guys, and welcome back to Lathe's Workshop. So the mini lathe project, part 6 already. It seems to have flown by. Yeah, let's see where we get to on this one. I think we're going to do a bit with the motor bracket, so we'll go straight to the machines and get on with it, shall we? So I'm looking at putting the motor in this sort of area here behind the machine. This is the headstock end, obviously this is the back, what we're away from the operator. So first thing I did, as it stood, the feet were on the bottom of the motor here, so I've taken the feet off and changed the location. When it was that way round, my electrical connections were a bit, you know, they were in tight. I mean, I can't turn this box, I believe, but it's easy to move the feet. So I'm thinking it's going to sit about here, and rotation here will do tension on the belt, you know, by rotating it. So what I'm thinking of is a plate on here which is hinged, so that'll sit on the plate, which will be in the right place, and then we can hinge it up or down to adjust the tension on the belt, and we can rig something up to be able to push it downwards, as it were, to keep tension. So I haven't decided on the type of belt yet. I was thinking of going along this sort of CNC type tooth belt, you know, the modular belts, but yeah, I'm not sure if I want to go down that route. I'm thinking of like a multi V-groove belt, one of the ones with the little tiny V-grooves in, something about 20mm wide, and that way I can make the pulleys to whatever diameters I want, and it's not like trial and error. I can work out the speeds I want, you know, have the smaller one on the motor and a larger one up here. You know, I can play with it if I can make my own pulleys, so that's the way I'm going with that. So yeah, basically I have a piece of aluminium plate here. I think the first thing I'm going to do is make a foot plate for the motor. So yeah, we've got this sort of hole pattern here, and that plate will just about do it. So I'm going to make a plate that fits on the bottom of the motor on the 4 holes on the mounting place, base first, and then we can drill and tap, do whatever we want in the aluminium plate to be able to mount some hinges to it. So that's the route I'm going down. So first thing, make a plate. So just blocking up the plate. It's stuck up a bit far out the vise, yeah, I know, but it works and it's okay. And I wasn't going crazy on the cuts. Let's just do the other side out of the vise, I think. Where's my little key? Oh, losing the plot. Can you see it, guys? Where is it? There it is. So yeah, I basically just squared that up to the bed with my square. Okay, just deeper the other side of that. Hacksaw this piece off the stock. Just check it for square. Looking good. Okay. Pop that down that way in the vise. Left a few mil on. It took a mil or so to square up my hacksaw cut. This is the square end of the stock. I think we should be good here. Okay, so as I said, it's just blocking up, guys. So my hole centers were 90 by 112. So I've offset, I found a center line on the plate. And 56 is my number, 45 and 56 offset from center in all 4 directions. So I'm just going to spot these plates. So that's it. That's the 4 holes, all done and in the right place to be able to pick up on the mounting bolts on the motor itself. So let's just come back out the way. There we are, 4 holes. I squared the plate up on the bed first. Usual scenario, you've seen me pick up holes before. While I got the plate up, it's going to hinge in this direction. I've just put 4 more holes in, 40 centres, 35 centres, so that I can bolt on a couple of pieces of steel to the underside of the plate, which are going to have holes drilled in them. Obviously they'll be cut off, but they'll have holes drilled in them, which is going to form part of the hinge. So there'll be a pin going through and 2 other blocks bolted on the lathe. You know, yeah, I just thought, while I got it up, set up nice and square, we'll put these holes in, and I've written down what they are so I can replicate the hole centres going forward. So yeah, that's what they're all about. I just knocked up a couple of these steel bars off camera and bolted them in on the bolt holes that we put in earlier. This is going to be the underside with the motor sat on top. I do need to shorten these bolts. In fact, I may not need to. We'll have to have a look. But yeah, I will shorten the bolts. So I need a cross hole now for a hinge pin. I'm going to come in, it's sort of 19-20mm stock. I'm going to come in maybe 9.5mm, and I know I've got some 3/8 silver steel, so I'm going to drill and ream holes in the pair of them, 3/8 in the centre height. So that'll be the next step. So I've centre drilled them both, just swapping them round in the vise. You can see I'm using my stop. I picked a position, 9.5mm. I've got them both orientated the same way round. That's a 6.5mm drill. So it's that one drilled. So yeah, we're doing swaps on these. So that one out. Put the other one in, which I've already centre drilled. Okay. And drill that one. So we'll swap over to a collet. I'll have a quick squint. See what imperial drill or metric drill I've got, sorry, that's under 3/8. And then we'll get a 3/8 reamer in there. So that's another step completed. I had an offcut of that 3/8 as well as a long bar. Let me show. I've still got a big piece of that 3/8 silver steel to make my pivot rod with. These are screwed down tight on here, and the 3/8 does line up through the 2. I tapped the bar in through the 2 and then locked these down in position once it was in, so just to make it easy. And it's a real good fit in there. Literally it was a tap fit all the way through. So where this pivots, I was toying with the idea of putting a full rad on the end of here, but there really is no need. I'm going to put 2 nice big 45-degree chamfers on here and make sure I leave enough clearance when I do the mating halves, which are going to go outboard. So yeah, I'm thinking of putting a longer shaft in and having the outboard pivots further away so that this can be adjusted back and forth for alignment, and I think I am going to do that. Going to give myself, sort of good 20mm back and forth play from where it looks about right, and then it can't come back and bite me later when it's got to move over a mil, So that's my thinking there. Built-in adjustability. So just blocking up some parts. Okay, that's the second one done. So I got 2 blocks the same, using the stop method again, which are going to be for the fixed part of the hinge on the back of the base. Now I'm probably going to bolt these on with some nuts on the inside of the box section. I could weld some nuts on, I suppose, but yeah, I'm just going to bolt them on with some nuts and bolts onto the side of the box section when it's done. So that's that part. We need some bolt holes in here now. I'm going to take them both out and deburr them. Well, I've already taken one out, so we're going to deburr these. They're both the same length, and then we're going to look at how we're going to set these up. So I put a couple of steps on the outside. That's the last cut. Well, that's to depth. Okay, so if I just step across now to my 0. So I've basically been doing the same depth and distance in X on all 4 sides, or 2 sides of both blocks, against the stop. So I know my step height and width is identical. So there's the other block, complete. That's that one finished. So we'll move on to drilling some holes now. I'll centre drill that one. Just a little bit of metalworking fluid on there. We'll swap over, we'll do a series of drilled holes till we get up to a reaming size, then we'll ream out the holes. So, yeah, it's coming along. So just some 5.5 mil holes in here will do the trick. That's that done. Swap over to the other one. And same again. Spot of fluid to be kind to the drill. And on to the next one. So we deburr these, and I need to put a couple of grub screw holes in to be able to hold the rod solid in these blocks when it's in there. It's a reasonable fit on the reamed hole, but we don't want it vibrating out. So the wall thickness here is a bit thin. You know, it would do it, but it's a bit thin. I'm thinking of coming in from the side here. I think actually if I went for something like M4, I'd get away with it there. So I think that's what I'll do. So yes, that is what I'm going to do. Right, deburr these and we'll set that up. So I've centre drilled the 2 holes. 3.2 mil drill now. Ready for the M4. Switch that off, I haven't got a lot of room there. Pop that one out. Pop the other one in. Nip the vise, and we'll drill that one. I'm going to try this. If there isn't enough thread for M4, we'll have a play with something different. So, yeah, there's a bit of wall thickness there. We'll see how it goes. So it's coming along nicely now. We got the mounting plate bolted to the bottom of the motor with 4 bolts. There's the 2 brackets, the hinge rod, and the blocks that are going to mount on the box section. So obviously I put a couple of grub screws in the top of these 2 blocks to lock the pin in relation to the box section, and then the motor can slide up and down on these 2. And I did go ahead and put a couple of grub screws in there to lock it in position once I've found the final position where it's going to go. But that gives me adjustability up and down the bed to align the output shaft of the motor and the pulley on the motor with the pulley on the back of the headstock to get it in line this way. So yeah, that was my thinking there. Just give myself, you know, 20 mil either way to play with. Yeah, I chopped the top corners off the blocks, you know, just a couple of 45s to give me room, swivel room, although there is a distance between this space and this space in the horizontal, or when the motor's horizontal. So yeah, so far so good. I'll offer it up to the machine and you'll see an idea of what I got in mind. So if I just grab the motor and put it in position roughly where it's going to go, I mean the pulley's going to go roughly here. So I'm going to do a starting point, probably, in fact, I think if I put this space in line with this space, I'm not going to be far away. So I think, yeah, that's probably what I'm going to do. I'll do a measurement from this space back to that block and set it the same distance back and then do the other one to suit. So yeah, that's the general idea, and then obviously the motor will hinge on that plate to tension or release the belt. So that's my thinking. So there we are. Yeah, that's where we are at the moment. So I'm 10 minutes down the road and I bolted the two blocks on with M5 bolts. I did drill and tap the box section and I thought there may not be enough meat, so I've dogged them down and there's no sign of them ripping, so I think I'll get away with that without having to put nuts on the inside, but I could reach and put nuts on the inside if I had to. Okay, talking about the inside, let's show you the end of the box. Let's do that in one hit. Ends of the box section. So at present they're open, nothing in there. Various discussions have been going on and people coming up with various ideas. My original thought was to weld the ends up, drill and tap a hole in one end or weld a bolt onto it, and you know, with a plug which would screw in, and fill the thing with concrete. But then, yeah, I don't know, you know, how it would fill with concrete. So what I'm going to do, and it was several people suggested to remove the drumming noise, I think welding the end solid with some 3mm plate either end. I'll put a hole in this end with maybe an M16 nut on it and an M16 bolt, and I'm going to fill it as full as I can possibly get it with sand. Some nice dry sand, and I'm going to fill it with sand. So that's what I'm going to do with it, and that will obviously give it a bit more substance. The sand will absorb a lot of the vibration and what have you, and welding up the ends of the box will also give it greater stiffness in the box. So yeah, that's where I'm going to go with that. So I've been playing around cleaning up some of the bits and pieces that go with this little mini lathe, and yeah, the hand wheel here, it was really glued up in here with all sorts of muck. I'm thinking to myself, yeah, it's wide open to muck getting in where you turn the hand wheel and this wheel runs on the rack. So I've made up, well, I've drilled and tapped 4 little holes, made up a little plate which sits on there, and that'll stop a lot of the gunk going in the hole. So yeah, that's just a 5-minute job when I had a piece of tin, chopped it out, drew round it, bolted it on, filed round the outside, filed out a hole in the middle, you know, just a clearance, and that's it, it's done. So happy days with that. Yeah, I've seen a lot of people do this, put a cover on here, whether it be a piece of perspex, double-sided tape, what have you, but I have got room for the 4 little screws, and yeah, job's a good one. So I've been thinking about the sort of belt I want to use, and you can see this is the sort of thing. This is a 7-groove belt. What is it? I've got a ruler. Have I got a ruler? I have. Yeah, and it's about 17mm wide. Okay. This is a 7PJ. That's the type of belt. 7 is the amount of grooves. Don't know what PJ means, but 451 would be the length of this belt. So yeah, if I pretty much put it on there, it's about 210, 225, something like that. So yeah, 451. Well, it's not the belt I want, but it's the style. This was just a sample I've got, just to see, you know, the general idea. So I need to know basically on the machine what length belt I'm going to need. So I'm going to need to know the diameter of the two pulleys and the distance between centres. I think that'll get me in the ballpark. So I'll take you over to the motor and the headstock, and we'll have a look at what the centres are going to be. So I've just mounted the motor up on its bracket, and the ideal scenario is that this motor is going to sit pretty much 90 degrees to the bed, which allows me all that extra for stretchy belts, and if I get the belt length wrong it can come further up as well. So if I just sit it on my chest here somewhere, holding it up, and look at the centres, and up a bit, I think, yeah, up a touch, right, okay. Centre of that hole, the centre of that spindle, 225 mil. So there's my starting figure, is going to be 225 mil. That's to the centres. So we already know our belt's going to be at least 550 long, but we've also got to go around whatever pulleys I use. So that said, this motor running at 400 volts, there's a plate on the side, which is what it's going to be running through an inverter, is going to run at 50 hertz. We'll do 1390. So I think the slowest speed I'm likely to need for this machine is going to be about 350, something like that. So if I did a 2-to-1 ratio where the pulley on the motor is half the diameter of the pulley on the spindle, at 50 hertz I'd be doing about 700 RPM. Now obviously I can drop below 50 hertz, I can drop down to 25 hertz. So at 25 hertz we'd be doing 350 RPM, which is my sort of minimum speed. And then that will allow me to go then, so 50 hertz would be 1400. So if I was doing 100 hertz I'd be doing 2800. Would I? So I'm confusing myself. At 50 hertz 1390, but I've halved it. So at 100 hertz I'd be back up to my 1390 again. 1390 spindle speed, which is not fast enough. So I can't do 2-to-1. So if I did 1-to-1, same pulleys on both, at 50 hertz the motor would be doing 1390 and so would the spindle. 25 hertz, let's say, I'd be doing 700, and at 100 hertz I'd be doing 2800, which is probably about as fast as I'd want to go. Yeah, I'm wondering, what if I did 2-to-1? No, sorry, 2/3. So if that was 30 mil, that'd be 20 mil, that idea. I think I'm going to go 1-to-1, and we're going to try it. So I got my little sketch. We know that the centres, between the centres of the two pulleys, with the motor and the spindle, 225. So the belt is going to need two pieces 225 long, which is 450. And then it's going to need enough belt to go halfway round a 47, I'm going to call it, diameter pulley. So pi d, so 3.142 times 47 is 147.674. Yeah, is that right? 147.674. We'll call it 150. So 75 mil belt round there, 75 mil belt round there, so it's another 150 mil long on the belt. So my 450 and the 150, my belt lengths to go around here, you know, ballpark figure, and this is not stupidly accurate, it's going to be a 600 mil belt, which is what I'm likely to be able to get hold of. So I think I'll go to Tinternet now, have a look what belts I can get hold of. If I can only get ones that are longer, I'll up the pulley size. If I can't get them that, you know, if it's a little bit longer, we can drop them down, that sort of thing. But I think the idea is that I can make up two pulleys 50 mil diameter, set the belt in there when it arrives, whatever it is, and then see what adjustment I got to make on pulley diameter, you know, if it's a bit short or a bit long. So that's easy. That's what I'm going to do. So jump on the internet, order a belt. Well, there we are, 600 mil. 600 mil for the belt, or 600 mil for the built, whatever way you want to put it, really. So yeah, you see, sometimes I get it tied up even though I can waffle quite well. Anyway, that said, I can order the belt. I'll probably order some of the electrical gear I need for the stepper motor for driving the lead screw at the same time. Maybe order some paint as well. So anyway, guys, thanks for watching, thanks for subscribing, and we'll see you all very soon. Cheers now.